So if you recall, we were basically talking about transitioning from DNA to codons, which is RNA in little groups, the three groups of three, to the proteins that actually manufacture. And now we're going to think about what would it be like to actually try to transfer a lot of that material at the same time? Could we create animal-human hybrids? It's a very nice video here. You can watch it in the notes. But as we go forward, one of the reasons we haven't actually accomplished this already is very serious ethical problems with using human embryos for anything other than human beings. So Japan has just lifted this, and actually just recently in the last few months, we've actually seen the first animal transplant. We'll get to that in a second, but they've just started the process. This was very recently that we've started the process that allows you to use embryological tissue from human beings as well as animal tissue. So the way you do that is you actually take stem cells, which are basically the starting point of human beings, and you take them and then you kind of freeze and roll back a mouse embryo in such a way that then the mouse embryo cells are no longer quite sure what they are. And then you insert human DNA into that situation. And suddenly that mouse embryo is like, oh, okay, I guess I must be this now. And so this is basically, they basically create about 1.1 to 4% human cells. So you can actually start generating human cells from a mouse embryo. Technically speaking, these are related to cybrids or cytoplasmic hybrids of creatures. And here's a picture of what the naive mouse cells look like when they're primed to accept human cells. And here's the naive human cells and the iPS cells putting into the mouse embryo. So as we look at this, it's basically you're reprogramming these progenitor cells and put them into a conventional petri dish. Then you actually kind of alter them chemically. Then you actually take the edited embryo of a mouse cell without its own DNA. You make a chimeric embryo. You put the iPS cells in there, and then the mouse actually, or the pig, or the sheep, or whatever is the gestational animal, will actually develop a human organ or sit a fetus inside an animal because you've basically taken the egg and taken out the DNA and put in human DNA. So while this is very exciting for people who are trying to use this to create human organs for people who need them, this is not really very ethical from a standpoint of you're treating an animal basically as if it has no worth without the human organ. A lot of people are arguing, hey, what we should do instead is make it a lot easier for people, human beings who are in accidents, to donate their organs, and that would solve a lot of the problems. And so I looked into this, and it looks like you could. I mean, there's a lot of problems with the US system. Right now, you are supposed to opt in rather than opt out of organ donation. By simply reversing that, reverse it so that you have to opt out of organ donation. You have to check the other box. You have to do something to not have your organs donated. You can really, really increase the amount of organ donations because most people don't really care. They haven't thought about it deeply. They don't really care. They're opting out just because they opt out, because they're not choosing to opt in. So if you reverse it, suddenly everybody's opting in by default. So opting out or presumed consent could have added between 4,000 and 11,000 life years for more than 500,000 patients on the waiting lists for organ donation. So there's really a low-tech solution for a lot of these organs. So it will actually decrease the wait list by about 52%. So it won't resolve if you need an organ at this point, it's a really long wait list. It's very hard to get through, but about half of that could be taken care of by simply making people actively opt out of organ donation rather than opting in. But it's not going to solve the whole problem. So we may still need animal organ donation to solve this issue in terms of getting transplant organs for people. We weren't, at the time I wrote this, in the place where we could actually get these organs ready, but since that time, this is only last year or a year, 2 years ago, and since that time, it's actually become possible. So then we have to deal with the ethical questions of, should we actually do this? Is it ethical? And then ask the question, is it ethical to just remove or to add human tails? Is this something that we'd want to do? And one of the things you should consider about this in terms of the ethics is that we literally had fish gills in the womb. We developed our faces from what were originally fish gills at some point in the embryological development. So we're just reversing back more than